Now, in exercise C, we want to verify this expression that I've written up here. And there are different ways of doing this. You can just calculate whatever you have on both sides. But since we're up for a bit of late night fun, let's do it a fun way. So the way I would do this would be to say, well, note that what we have here is, so note that what we have on this side is a second degree polynomial in y, and that is also the case for this one here. And we can recall that if two n degree polynomials agree on n plus 1 points, then they are equal. Therefore, the only thing that we really need to check here is that these two expressions agree with each other on 3 points. It's the same as, if you have a linear function, then it is uniquely defined by 2 points. Then a second degree polynomial is uniquely defined by 3 points. So which 3 points do we want to check here? Well, the 3 points that we want to check for are those points that make these expressions easiest to calculate. And therefore, I suggest choosing y equal to m, y equal to 0, and y equal to m plus sigma squared. Because for y equal to m, you can see that the left-hand side is equal to minus y, because the entire first term is equal to 0. And the right-hand side is equal to m minus m. So what you get is, oh, sorry, I think we have to take to the second here. Yeah, so on the right-hand side, you get sigma to the 4th divided by 2 sigma squared minus m minus sigma squared divided by 2. And what you have here is then what do we have? You have sigma squared divided by 2 minus sigma squared divided by 2. That's 0, so you just have minus m. And what you have on the left-hand side was minus y, but y is equal to m, so that is equal to minus m. Therefore, in this case, the left-hand side and the right-hand side agree. Now let's check for y equal to 0. In that case, this term is equal to 0. And then you get, on the left-hand side, m squared divided by 2 sigma squared, since y is equal to 0. And on the right-hand side, what you get is, well, something that seems a bit more complicated, but you have m minus sigma squared, so that is equal to m squared plus sigma to the 4th plus 2m sigma squared divided by 2 sigma squared minus m minus sigma squared halves. And what you now see is that the plus 2m sigma squared divided by 2 sigma squared, they cancel out with the minus m, and this term cancels out with this term. So on both sides, you have m squared divided by 2 sigma squared. Yay! Last one you want to check is for y equal to m plus sigma squared. In that case, what you have on the right hand side, on the left hand side, what you have on the left hand side is equal to, well, let's see, sigma to the fourth divided by 2 sigma squared minus m minus sigma squared. And that is sigma squared halves minus sigma squared minus m. So that is minus m minus sigma squared halves. On the other hand, on the right hand side, well, that one is easy to calculate here because the entire first term just turns to 0 and you have minus m minus sigma squared halves. There we go. So we've checked that these two expressions agree with each other in 3 points. And since they're both second degree polynomials, that means that they agree with each other on all points. So we conclude, since left-hand side is equal to right-hand side for 3 points, and note that these are 3 different points because m and 0 and m and 0 and m plus sigma squared are different, at least if we just choose m to be not 0. Since they agree for 3 points, then we have that left-hand side is equal to right-hand side for all y. There we go.